All right, so today's topic is inverse functions. I know we had that quiz make up today. I don't want you studying for that while I'm doing the notes. So I know I say it every day anyway, but please close your computer windows pretty please. And you need a pencil, take your notes. Grayson, will you close your computer lid? Okay, so our topic to start with is just review. And then there's like one kind of inverse formula that we'll go through together, although this isn't connecting. I don't know what's going on with that. And then tomorrow, like if you flip ahead in your notes, tomorrow there's several formulas we're going to go through, but today's just a singleton, just one single formula. There we go. Okay. Oh, so first thing, like I said, is review stuff like about inverses. And an inverse graphically is a reflection over the line y equals x. And then numerically, it's just flip-flopping the x and y values. So you learn about these, I mean, probably way back from like into math 1 or math 2. So if I had, for example, something that was like a squiggle going this direction, then it would flip over the line y equals x and then would be going over here. The notation is a little -1. That's not a power. That's a notation that means inverse. And that can be confusing because we're used to seeing -1 as power, but this means inverse, not reciprocal. That means x's and y's are switched. F and G are inverses of each other if you plug them into each other. So if I do a composition one way and I get x, and then a composition another way and I get x. So if you do the composition both ways, and if they both come out to be x, that's the way that you can prove you have inverses. And then kind of the last fact, which is what we're going to focus on a lot today, like our calculus portion, is that graphs of inverses have reciprocal slopes. So if I had a graph, I don't know, let's say I had a cubic over here, and a reflection, and then it's reflected over here, then whatever this point is, like the slope there, let's say that's the point 110, and let's just say the slope is 2. Then over here, that would compare with the ordered pair 10, 1, and the slope would be 1. Like the slope here is a reciprocal of that slope, not an opposite reciprocal, just a reciprocal, just a flip. Okay. We're used to hearing about opposite reciprocals, and opposite reciprocals are for perpendicular lines, but these lines aren't necessarily perpendicular, but they're inverses. So inverses have slopes that are reciprocals. And we'll use that fact a lot when we get to the calculus portion of our notes. Okay, so then again, this first part we're going to go through is review stuff. So first thing, just kind of reviewing, find how to find an inverse and sketch. So the directions give us x squared plus 4. So if we graph, so sketch a graph for x squared plus 4, that's a quadratic of 4. But the directions say only to keep x greater than or equal to 0. So actually only going to keep this half of the graph. This would be my graph. So that would be the original we call f of x. And then the directions say find the inverse. Okay, so to find an inverse, I'm going to rewrite my equation so I have x's and y's instead of f of x. And then I switch x and y. So that's the property of inverses, that x's and y's are switched. So it's going to be x equals y squared plus 4. And I can solve for y, like solve for the new y, by subtracting 4 on both sides. And then taking a square root on both sides. So I switched x and y, and I solved for the new y. So here's a little bit of a trick, though. When I take square root on both sides, we're so used to doing plus or minus, right? Like pretty much always we write the plus or minus in there. It's a little tricky with inverses because with inverses, a lot of times when I go to flip that to the other axis over here, I get a non-function. But we want our inverses to still be functions if we can help it, which means it's got to pass the vertical line test. So instead of just automatically putting the plus or minus in, I'm going to look back and see if there's anything in the directions that helps me understand like what my new range would be. So like if my domain was x greater than or equal to 0, then that's going to convert to y greater than or equal to 0, meaning I'm not going to use the plus or minus. I'm just going to use the positive part only. And so I would write this as f inverse of x is just the positive square root of x minus 4. And so that's a square root graph shifted to the right 4, which would be here. And that should look like, if I was going to reflect over the line y equals x, it should look like if I was to take this as a piece of paper, basically, and fold it on that line, that this part would match up with this part. And so that's a graph. That's the inverse function. No calculus there, just kind of reviewing what inverses are, like how to find an inverse. So we switched x and y and solved for the new y. Okay, questions on that one? Question? No, no question. That was you nodding your head. Okay. All right, second one asks us to prove that the two equations are inverses. And I know we can kind of go along that same thought process of like take x and y and flip-flop them and see if you get the other equation. But what we're trying to use here is the property that if we do f of g of x, we get x, and if we do g of f of x, we get x. We're just trying to show that the composition works in both directions. So f of g of x means I take this equation and I plug it into x. Oops, sorry, I missed my x. We're trying to get f of g of x is x and g of f of x is x. Okay, so if I'm going to do f of g of x, I take the equation g of x, plug it into the f of x function. So it now looks like this. 3 minus 4, big parenthesis, 3 minus x over 4. And then these 4s can cancel. And then when I distribute the negative, the 3s cancel, and I get just x. So I'm going to do like check mark. It worked, go in that direction. And then I'm going to go the other direction, which is where I take f of x and plug it into g of x. So this plugged into that one. So that's going to be 3 minus big parentheses all over 4. If I distribute the negative, the 3s will cancel. Oh, wait, sorry. Positive 4x. And then 4s cancel, and I just get x, check mark. It works both directions. And so to prove two functions are inverses of each other, you do a substitution both ways. They both come out to be x. Again, it's supposed to kind of be like a review concept. Any questions on that one? You won't have a lot of questions like this on assessments. This is more just like helping us remember what inverses are. Okay, so now you gotta hunt and find the pages, like the three notes pages. It's like a search and find to make sure you're on the right spot. So find this table. This is just x and f of x. There's a couple pages on notes or a couple tables on notes. Okay, so f inverse of 7 and f inverse of -4. So my table is f of x, and it's asking me for f inverse. So f inverse of 7 is the same thing as saying, where does f of x equal 7? That's because x equals 7 on the inverse function will correspond with y equals 7 on the original function. Okay, so I'm going to go down my column of f of x at 7, which happens to also match up with 7. So this is 7. So let me show that again, just because I know some people were writing. So f inverse of 7 means the y value on f of x is 7. So I went down my y value column till I got to 7. And that happens at x equals 7, which means on the inverse function, If x is 7, then y is 7. I don't like that we have 7 and 7 there. Let's try the next one. Okay, so f inverse of -4. Okay, to find that, I'm using the table of f of x. So on the table of f of x, I'm trying to figure out where is the y value -4. So the y value is -4 at 6. So that one's 6. It's kind of like the order pair here is -4, 6, and the order pair here is 6, -4. So when you're asked to find f inverse and your table gives you f of x, this value is plugged in as a y value. Because you're being asked about the inverse function, not the one that's in the table. And so you got to switch the x and y. Questions on that one? Questions? Okay. All right. Then our next one, we're going to finally bring like some calculus stuff into this. I'm going to try to go through this like nice and like really, really slow, probably more slow than you need me to go through it, because essentially what we're doing here is what we'll have to do with our one single formula that we're learning today. Okay, so the way I think of these, if you're asked about slopes on an inverse function, is in my mind what I do is I divide my workspace up into two pieces. And on the right side, I put all the information I have about my inverse. And on the left side, I put all the information I have about the original. And then I'm going to kind of work through this. And that way I'm kind of like, that line helps me like divide out in my head. Like the two different equations are different. And as you do the calculus problems, they're going to give you some information about the original and some information about the inverse. And like I have to sort it into the two things. So when I'm given F inverse, so I'm given this order pair is 2, 4. Okay, so on the original, the order pair here is 2, 4. What would the order pair be on the inverse? 4, 2. Good. Okay. Very good. 4, 2. Excellent. Thank you. And that step will honestly be the hardest step when we get to the calculus stuff. It's like figuring out the ordered pairs in the right order. Okay. Then I know the original here is x squared. So I'm going to use that and solve it out for a second to figure out the inverse equation. Okay, so my inverse equation, so kind of like side note real quick. The original is y equals x squared. So I switch x and y. And then when I go to solve for y, I get plus or minus radical x. Okay, now how do we deal with the plus or minus? The way you're going to deal with the plus or minus is you're going to look at the y value and just determine if it's positive or negative. Y value is positive, so I'm only going to keep the positive version of the square root. And that is super tricky. Sometimes they give you a negative and you keep the negative. Sometimes they give you a positive, you keep the positive. But my equation over here is F inverse is positive square root x. Yes, question.
Why does it work like that?
Because they're giving you an ordered pair that the graph goes through, and when they're saying f of x, they want your inverse to be a function, like f inverse. And so to make it a function, you can't have a positive square root and a negative square root, or else it won't pass the vertical line test. So you're going to pick either the top or the bottom, which goes through that point. And since you've got a positive y value point, you're going to choose the positive one. Okay, any questions so far? So we got our points, we got our equations. We're just going to do the slope of each. So show the slopes are reciprocal. So I'm going to do slope on this side. Oh, how do we get slope again? Now that we're in calculus, we just do derivative. Take a derivative. You don't have to do y2 minus y1. We just do power rule is 2x. And so then on this side, my derivative at 2 will give me the slope. So 2 times 2 is 4. And on the other side, my inverse, my notation gets a little crazy here. F inverse prime of x. So F inverse prime is, so think of that as x to the 1/2. I get 1/2 x to the negative 1/2, which is 1/2 square root x. And then when I'm working with inverses to find the derivative, I'm not gonna plug in the same x value because my x values and y values are flip-flops. So I'm not using 2, I'm using 4 because I'm on the inverse side. So I'm gonna plug in 4 and I get 1/2 square root of 4. And so square root of 4 is 2, so this works out to be 1/4. And yes, these are just reciprocals of each other, not opposite reciprocals, just like the flip of each other. So again, I kind of divided my workspace in half. I listed out my order pair and my equation on the original, my order pair, my original, or my order pair and my inverse equation, and then derivative, and turns out the slopes are flip of each other. So when we get to like our calculus portion of what we're doing today, it will look very similar to this. Okay, there's gonna be a couple steps that are a little bit different. And that's because I'm only gonna make you take the derivative once. Because really, if I can take the derivative over here and get this answer, why do I even need to bother doing all this? I can just say, well, I know my properties of inverses, so this answer would be 1/4. And that's kind of what we do when we take derivatives of inverses. So it'll look a little bit similar to this question.
So this is like the easy part.
It's just like this. It's almost just like this. The only part that's gonna make this a little harder when we get to our calculus is that solving for this ordered pair can get a little harder. Yes. Okay, so let's look at the equation and then we're gonna try it. So our property or like equation today. Oh, you gotta search and find the right page. Is it just next to it? Never mind. Okay, just right next to it. Okay, is derivative of an inverse function. So this is the formula and it looks like, it just looks super crazy. So F inverse prime. Okay, so on my 2 halves on that bottom right corner, when I had the F inverse prime, that was the flip, the reciprocal of the inverse value, because I plugged in 4 instead of 2, plugged into the derivative. So it's the flip of, like if I take my, remember how I had 4 over here? I'm getting my numbers confused. It was 4 over here, I think, and it flipped to be 1/4. Like this 1/, is saying it's flip of the inverse value plugged into the derivative. Now, I think that's a hard formula to memorize. Honestly, if you were to ask me to sit down and like write it out, I would have to concentrate on it for a second. Because when I do these problems, I don't memorize this. I just work on those 2 halves and like sort it out and do the derivatives. Like I don't worry about this process so much. It's just knowing that there's a reciprocal relationship, which means flip. And so as long as I remember that flip step, you don't necessarily have to memorize this as much, but this is showing what we just did. If you want to think of it as steps, and we'll try one of these and come back to this and reflect on it. So like find the inverse coordinate by plugging in x for y. So this is like when I do my 2 halves, make sure I get both ordered pairs figured out. That'll take a little step on these. Then I find the derivative, then I plug in the inverse value and then flip it.
So like the thing where you do where you split into the 2 halves, you have to have like the original function to do it.
Right, and they'll give you that.
Okay, so
Yeah.
they'll never just give us the inverse.
Right. Yeah, so the problems, I mean, they can kind of come in different forms, but they generally will give you the original function, but ask for the slope on the inverse. And so you're gonna find your slope on the original and just flip it over. It's basically what we're doing, like figure out the coordinates, then find the slope on the original and then flip it over. And then this is kind of like another way that you could work on remembering the formula if it helps, is think of F inverse as a G of X, because some of our problems will write it as a G of X. We'll go through that. So like based on our composition rule, like our property, if I was to take the derivative on both sides, I would have a little chain rule deal, like derivative on the outside, leave the parentheses alone, chain on the derivative of the inside, that side's 1. And then you could divide, and this gives you the same thing as that other one, just with a G of X instead of F inverse, if you'd rather write G instead of F inverse. Let's try. I really think it will help to see a problem, and then we'll come back and look at this again, and it should make more sense. Okay, so here's how the problems will look for you. So the directions, oh yeah, you got to search and find the page. Sorry, our copy machine was not cooperating super well, so wouldn't staple or hole punch, which we usually hole punch them on our own anyway, but. Okay, so this is telling me that I want the derivative on the inverse. Okay? But then when I look at what's given to me in the problem, they don't give me the inverse. They give me an original equation. But that's okay, because if I can just get the slope on the original, I just have to flip it. And that will give me the derivative on the inverse. I just have to make sure that I like sort my information carefully. Okay, then they give me this letter A. So I'm like, okay, well, what is A? Because of the directions, so the directions up here, A is the X coordinate here. But do you see the A up here? So because of the directions, that means when I divide this into two pieces, so this is my inverse side, this is my original side. This is telling me 2 is an X coordinate on the inverse. It doesn't give me the Y coordinate. But still, based on that fact, I at least can fill in that on this half, my Y value is 2. Now, I know you could go through and flip-flop X and Y and solve for the inverse, but we're not going to do that because on like this one, it's possible, but on some of the other ones we're going to do, it's not possible to solve for Y and like be able to isolate Y and get the function to take the derivative of. So we're not going to worry about doing the inverse of this, even though I know you can. That's what you're thinking about. Allie, question. It does on F inverse, yes. But then remember, this is like dividing my problem into two pieces. So if the inverse has an X coordinate of 2, the original would have a Y coordinate of 2. Okay, so my job then is I've got to finish figuring out what else is in that coordinate before I do my derivatives. And the only way I can figure out is using the one equation that I have, which is an original. So if my original is for X minus 4, I can use that equation with Y equals 2 to figure out the missing part of the coordinate. Okay, so I'm going to plug in 2 for Y. And I'm not doing a derivative yet. I'm still just like trying to work out the coordinate. This is probably the hardest part. Square both sides. Add 4. Make my line a little farther. So I'm able to then figure out what the coordinate is. Any questions on getting the coordinate? Okay, so then how this relates is if I take the derivative over here at 8, whatever number that is, I just have to flip it, and that will tell me the derivative over here at 2. So like my goal is to get this number, and whatever number that is, I'm just going to flip it over, and that will be my answer. So I only have the one equation. I'm not going to do derivatives on both equations. I'm just going to do the one derivative and then flip it over to get the other derivative. So over here, if I take f prime of x, think of this as a 1/2, and we've got this as a chain rule. So it's going to be 1/2 x minus 4 to the negative 1/2. And then chain on the derivative of the inside, which is a 1. So this ends up being 2 square root of x minus 4. 1/2 squared x minus 4. Okay, so I'm looking for f prime of 8. If I plug 8 in there, 8 minus 4 is 4. So I end up at 2 times 2 again. So this one is 1/4. So the derivative on the original at 8 is 1/4, which means the derivative on the inverse at 2 is 4. Just flip it over. So I didn't have to bother finding the inverse equation and its derivative. Like I get to skip doing all of these steps because I know this property that these two are reciprocals. And so I had to like kind of just summarizing the I'll get your question in a second. Kind of summarizing the process. I was given 2 as an x value, which is a y value over here. So I plugged it in as y on the original, solved it out to get the coordinate. Okay, then when I had the coordinate, I take the derivative of f, plug in the x value, and then I just flip it over, and that tells me the derivative of f inverse at the other x value at 2. Question.
You find the derivative, can you, like, so say you find a derivative like the first side with this math, can you just flip the derivatives then plug in 2?
Yes.
Okay.
Yep, so the question was, could you just like flip over the whole equation and plug in 2? Yes. Same thing. Oh, wait, did you say plug in 2 though?
Yeah.
Okay, wait, no, sorry. Okay,
And if you
on
flip it,
this side.
flip side,
Okay, I might have misunderstood your question. Okay, what I thought you were saying was, could you take this derivative right here and flip it over and then plug your number in? But you were saying flip it over and plug in this number?
Yeah.
No, you wouldn't be able to do that.
Okay.
Sorry, so like, okay, so I thought, so like you have to flip, so you could, I usually just flip the constant at the end. So you could flip this equation over, but that doesn't make it into the inverse. So you wouldn't plug in 2 because 2 is on the inverse side. You'd plug in 8. Let me go through the steps with you again to kind of summarize what we just did. And don't worry, we'll practice this plenty of times. It's the only formula we're doing today. Okay, so that's the same. We're doing 1 over. So that's like the flipping part. We had to find the inverse value and plug it into the derivative. So it's like, this is the work we're doing on the left half of the space to get the answer that we're looking for on the right half of the space. And kind of just as like directions here, find the inverse coordinate by plugging in the x value for y. So that was when we took 2, we plugged it in as the y value and solved to get 8. Then we just took the derivative function and then plugged in 8 and flipped it. Okay, let's try again. Okay, so I'm just going to divide my space in half again to make sure that I'm like separating in my head inverse information and original. Okay, so if a equals 7, that's telling us the x coordinate on the inverse is 7, and I'm looking for f inverse prime of 7. I don't happen to have an inverse function, I just have an original function. So now I'm going to look at my original information and say, oh, well, if x equals 7 over here, then y equals 7 over here. And I can plug in 7 as the y value and add 1 and cube root, which gives me 2. So because I now know that inverse value, all I have to do is take the derivative at 2 here, and whatever my answer is, just flip it. So my like harder step, like my primary work I'm doing is figuring out this coordinate. And once I have the coordinate, it's just derivative and flip it over. Okay, so then f prime of x is 3x squared. F prime of 2 is 3 times 4, which is 12. And then my inverse derivative at 7 would be 1/12. Okay, do we first of all understand why this is a 7 and this is like, do we understand why those have to be different numbers?
Because they're both x.
Yeah, they're like the x values on each individual function. So like that usually is the hard part. It's like getting that coordinate. And then the rest of it is just like taking the derivative and then flip it over. Okay, let's try again. Okay, so on this side, I know the x coordinate is 3. That means over here, the y coordinate is 3. Question.
So how do you know that A is on the next value of integers?
Okay, good question. The question is like, how do we know that that's where A goes? And it's because of this in the directions. Because it has the A here as like the x value with the inverse part. If it had just said f prime of A instead of f inverse of A, then it would have gone on this side. Okay, so to get this missing coordinate, we're gonna plug in 3 as the y value. This is a little harder here. So 1/4 x cubed plus x minus 1 equals 3. And I'm gonna subtract the 3 over so I can get a 0. I'm moving the 3 over to the left. The reason you want an equal 0 is because I'm hoping I can factor on the left. Oh, shoot, sorry, this is a 3. Mistake, sorry. Okay, then I'm gonna multiply everything by 4 just because I don't like fractions. So get rid of that fraction. This would be 4x minus 16. Okay, then I can't really factor because it's x cubed instead of x squared. And you're not allowed to just like factor out of the first 2 and not all of it. So, okay, so 2 things. One, you can either try to guess the number, which honestly, if you can believe it, is going to be easier. The other option, option number 2, is to do plus or minus p over q. And then do synthetic division to test for the zeros.
What's that?
I mean, we'll review that real quick, but I know you don't want to do that. So plus or minus p over q, all the factors of 16. Yeah, does anyone have one already?
Yeah.
It's
The answer.
And then you test values out by putting them in a box. Like, does this sound familiar to you? So you do like 1, 0, 4. You remember synthetic division? Probably would have been like a math 3 little remix. I do think it is literally easier to just guess the number. Like I would plug in 1 and see if you get 0. Then plug in -1 and see if you get 0. But you don't. Then you plug in 2 and -2 and 2 ends up working. It's 8 plus 8 minus 16 is 0. So let's go with just guessing. You will not end up with, you're not going to give you anything there that's a fraction. Like we're not going to make you guess 3.75. Like it'll be a decent number if you ever have to guess something like that. Like 1, -1, 2, -2, 3, -3. Okay, so I know x equals 2 is the rest of my coordinate, meaning if I need the derivative at 3 on the inverse, all I have to do is find the derivative at 2 on the original and flip it over. So derivative in this case is 3/4 x squared plus 1. And then I'm just going to plug 2 into that. So 3/4 times 4. So that cancels. So 3 plus 1 is 4.
1/4.
So then 1/4. Is it starting to make a little more sense now? Like again, I don't memorize the formula so much as like understand what's happening. Is that I'm figuring out like the inverse value and taking the derivative there and flipping it, and it gives me that answer. First question. Not to what we did yesterday. I mean, it can in a way, but like we're not going to go through it today. Yeah, question. Maybe 1/4. So this is your final answer right here. You can connect this to what we did yesterday with implicit. We just won't get to that level today. Okay, let me go back to the formula again. Okay, so this is what's given in the directions. That's what we're trying to find, the inverse derivative. But they don't give us the equation of the inverse. So we've got to figure out like the derivative of the original function, but plug in the inverse value and then flip it. So this formula, like this part of the formula tells us to flip, do 1 over, plug in the inverse value to the derivative of the original. Like that's what that formula is telling us to do, which is what we're doing in our like, you know, our dividing it in half and kind of thinking of it as 2 different things. That's what we're doing. But like you can also just find the inverse value, plug it into the derivative and flip it. All right, we're ready for a trig example?
No.
I think we're ready.
you having to do a chain rule?
Yeah, all these could have chain rule or product quotient, all of them, yeah. All right, so A equals 1, so that means I'm looking for the coordinate at 1. I'm trying to find F inverse prime of 1. But I need to find like the comparative number over here, which is 1 would be the Y value. So to find that, I plug in 1 as the Y value. Oh, trick. Then I got to remember, like, where does cosine equal 1? Does anyone remember? What'd you say? 0 is right. Good. Where else? 2 pi. Yep. So 0, and then 2 pi, and then 4
But
pi,
it's
and then
asking for
6 pi.
less than.
Now, if you look at this, yep. So this is like limiting the number of answers we can have. And then if anyone's wondering about this 2x, we leave that to the end. So we'll take care of that in a second. So we said it's 0, 2 pi, 4 pi. I know we're not going to use all these, but just like as a reminder, it doesn't hurt to review that. 2x, the way we handle that is like we leave the 2x there until after we figured out where does cosine equal 1. And then we divide everything by 2 on both sides. So 0, pi, 2 pi. But again, we're only keeping that first one because of this in the directions. Okay, so my order pair here is 0, 1. Here it's 1, 0. If I can find on this side the derivative at 0, then I just take that answer and flip it over, and it will give me the inverse derivative at 1. Okay, so now I'm doing derivative on this side. So f prime of x. Derivative of cosine is negative sine. And then I chain on the derivative of the angle, which is 2. So overall negative 2 sine 2x. And I want f prime of 0. So when I plug in 0 here, does anyone remember sine of 0? It's 0. It's 0. Sine of 0. Cosine is 1. So like at that angle,
Sine X.
the order pair is 1, 0. Cosine sine.
Sine's X.
Sine is
Y.
sine the y. Yep. Okay, so my original derivative is 0, which means my inverse derivative flips that over would be undefined. It'd be 1 over 0, and we can divide by 0. Yeah, D and E would work too.
Is there no difference between
I mean, not for the purpose of what we're doing. Okay, do you feel like you understand kind of the 2-column process? Yeah, okay. Question for you. Hold on 1 second, we're almost done. Okay, there's one more. We're almost done with notes. And I like this part better. I don't think first period liked it better. I think they like preferred doing the calculations. Okay, last thing we're gonna look at is if you're given a table instead of an equation. It's meant to make things easier. It really is meant to. But when they give you a table, it gets a little like sometimes they change the names of functions. So we're going to analyze the directions really carefully, which is this. G is the same as F inverse. So when they ask you to find G prime of 3, that is the same thing as saying where is F inverse prime of 3. Like that's what the directions are asking for. Okay, so when I divide my stuff in half, this side is going to be G because it's the same as F inverse, and this side is going to be F. And when it says G prime of 3, that means my order pair is a 3 on this side, and over here, 3 is the Y value. Any questions on that much so far? Okay, now the table is meant to make things easier. Because right now, if I had an equation, I would plug 3 in as the Y value on the equation. But I don't have an equation, I have a table. So I'm going to go to my table and say, where is Y3, which is here? And that's at X equals 4. And that's where the table is meant to make it a little easier because you don't have to do any like synthetic division or trig or factoring or solving to figure out that X value. Question. Well, okay, no, okay, because I think what you're thinking is like, could I go to X equals 3 right here? But that would be X equals 3 on the original, and they want the derivative at 3 on the inverse. And so that like 3 and 3 don't match up. And so that's why you can just go with 3. So you got to figure out like that missing value. Then if I can find F prime of 4, that would be the same thing. So I was finding G prime of 3, and I just flip it over. Like if I can get the derivative at this coordinate, it'll just be the reciprocal of the derivative at that coordinate. Okay, how do I find F prime of 4? I just use the table. I go to 4, and it's 2. And so this derivative is 1/2. And so I don't even have to like algebraically compute a derivative. I just get it from the table. Oops. Okay, let's try this again. Okay, so G of X is over here, F of X over here. I'm looking for the derivative at 4 on G. So I want to figure out how does that relate to F? Because then I can just like flip my answer over. Okay, so that means I look, where is the Y value for on F? So I go to F of X. I find the Y value is 4 here at X equals 2. So if I can just find F prime of 2, then I would just flip it and I would get my answer. So F prime of 2 is 3. And my answer is 1/3. Can I give you one to try on your own real quick? And then we'll be done. Will you find G prime of, let's be done 3 and 4. G prime of 1. G prime of 1. See if you can find G prime of 1.
Sorry.
So that's problem.
Yeah, are you done? So you go. See 1. Did you get 3 as the X coordinate? Okay, and then F prime of 3. Oh, 1. 4. Answer is 1/4. Did you get it?
I got
No?
one.
Dang. Okay, let's try again. Okay. So you're taking 1,
I got one too.
you're plugging 1 in as the Y value on F of X. Okay, so I'm like going here. My Y value is 1. That gives me X equals 3. So I know that like 1, 3 is on the inverse and 3, 1 is on the original. Because like my original is 3, 1. So if I can get the derivative at 3, then I just flip it and it will give me the inverse derivative. And my derivative at 3 is 4. So I can just flip it and 1/4. Okay, if you want to try one more real quick, G prime of 2. Correct answer was 1. 1, yeah.
I got one too.
You got 1/3. Oh, how do you get 3? Okay, so 2, G prime of 2 means I go to 2 as a Y value, which gives me X equals 1. Then I take the derivative at 1, which is 1. and then flip it. Okay. All right, we are gonna pause there for a moment. So we're gonna now divide up into two groups. So group number one, if you are like done with your 2.4 topic quiz and you want to go ahead and start working, like checking things off your checklist, this is what you're working on. Group number two is if you want to work on the retakes. When we get out of here, we get out of here 11:01. Okay, you got like 3 minutes to study quick. If you want to get your computer and try to review one quick problem. Real quick, needs 30 minutes to take it. Yes.
Is there a reason why like is it having those
Because a 90s twist, I love that. Our copy machine completely glitched out. We had someone here repairing it yesterday. So I think it should be like, we should be good to go. But it was just, I don't know, not working.
It can be